So this is the data set, and this is related to accelerometer. Nowadays there are a lot of wearable devices coming which is going to track the number of steps taken, calories burned, so on and so forth. And you can also install mobile apps. Fitbit has a mobile app for that case. You just need to install this, and if you place your mobile in your pocket, it's going to track the steps taken. For example, look at this. Participant 1 has started off, obviously any person would start at 0. This person has taken 1 step in 0.03 seconds. So this guy has taken 1 step in 0. The distance is 0.03 seconds. And this person has taken 2 steps. And from the start, for this 2 steps, the distance or the time taken was 0.06. In that way, it's captured. And easy traveling in the X direction, easy traveling forward or backward is given using your X-axis. Easy climbing the stairs or easy getting down is determined by your Y-axis. Easy traveling towards the left side or the right side is determined by your Z. In that way, each person's movement is tracked. Using these inputs, you need to cluster the people together, and here we have how many participants? I think we have close to 22 participants. So we have 22 participants. All the data is given, and we have 1,43,333 records. How do we cluster these 22 people? What kind of feature engineering is required? And that is when I've done some research and found that with this data given, right, this data set collects data from an Android smartphone positioned in the chest pocket, and they've collected the data from 22 participants. And in the dataset, original dataset, we had time taken per step, X acceleration, Y and Z acceleration. And you have to do feature engineering based on your domain knowledge, 100%. So when you do feature engineering using some research, using this article I've done some research, it says that if you position your mobile phone upright, Y direction is measured. If you position that in this left direction, only X is captured. Down, negative, right, negative, front up, front back, in that way. Now, all these are in meter per second square. Meter per second square. These are your international units, SI units. And how is it measured? The acceleration applied to the phone minus the force of gravity. So the gravitational force is subtracted from that. That is how you get this value. And this is all based on the domain knowledge, okay? Initially, I did not have any domain knowledge, so I had to do a lot of research and come up with this. And how did we extract the various features? Again, I've referred to various articles, and I felt that white papers also. And I felt that total time walked by the user, right? How much time did this person walk total is given using maximum time steps. So if you look at this participant 1, how many steps did he take? So if you just keep counting those wherever participant 1 ends. Oh, this guy has taken a lot of steps. Or let me scroll that and see how many steps. Right, there's a crude way of doing. I could have as well filtered, but I just want to show you the intensity of the data. Yeah, that's the reason why I'm scrolling now. If you're wondering on, hey, why don't you filter on participant 1? Yeah, that's an easy way to do. But I just want to show you how complex the data set was. Look at that, look at that. How much time did this person walk? Each step. I just want to, yep, here we go. Oh, hold on. Yep. Now I think I have to be a little slow. Yep. Come up. Yep. So this participant has taken close to 5,069 steps. 5,069 steps, and if you look at that value here, if you just take probably summation of that, you get the total time taken, maybe, right? I'm assuming. All right, so that is how the distances or time taken, time walked by the user is calculated. How many steps we have just seen that, and distance traveled left or right, uphill or downhill, etc. is calculated using S is equal to UT plus 0.580 square. Back to your physics, right? A is the acceleration at the current step. T is the time duration between steps. U is the acceleration at prior step. So all those values are given and you calculate that. And also you can calculate the velocity in X, Y, and Z direction using velocity is equal to U plus AT. And using all this feature engineering, I've come up with this data. And now this is how the data appears. Earlier data was in this way. Now we have enhanced in using feature engineering, we have got that. And based on this data, when we have done clustering, remember the success of clustering is only dependent on you successfully labeling that. So when we have used hierarchical clustering with average linkage, I've got a better cluster, and I could probably, or I could name it properly like as marathon walker, speed walker, average walker, and lazy walker. Here is a code. And I have not restricted myself only to one cluster. I've also done k-means clustering, and I've done scree plot using multiple techniques. Right, there is something called as NBClust package. You can also, try out using that. And yeah, you can either use WSS plot, which is going to give you the scree plot only, or NBClust. There are multiple ways, right? And you can look into the various values and then determine, yeah, based on aggregation. And I've also used PAM technique to see how many clusters were there, yeah, and what was really making sense. Yeah, that is how I have determined. And your dendrogram, k-means, and MEDIOS methods are more accurate, describing about 92% of the variability in the data. That is how we have concluded.